what types of errors or what type of correct responses or what type of misconceptions did you anticipate that they would have?
Well, I think that when I was planning this lesson, I mean, obviously it was derived from a conversation we had going over our practice test data from the park assessment. And I noticed that one of the problems that they did was finding the area of a rectangle. It was like an irregular rectangle where there's two rectangles on top of one another, but one of them was kind of slided to the right. So we wanted, in talking with Mia in second grade and our math consultant, we were talking about what kind of background knowledge they need in order for them to be able to solve problems like that. So we obviously were looking at tiling and having them figure out the area of irregular rectangles or just various shapes, closed figures. And I honestly didn't know what to expect. I figured that most of them would draw the tiles with the 1 square inch tiles that they had, and from what I saw, most of them did. One thing that surprised me was, and I think it was a good eye opener for me, was the one pair that actually counted all the lines.
Oh, yeah.
And I think that that was a good representation of some misconceptions that they would have had or that they did have. And I think it was good. And when I brought that to the students' attention, I think some of them were like, wait, I think we did ours wrong. But I think once we went around and asked for the solutions from everybody, then we're able to see that we're not focused on that. So I think one area that I wanted to definitely focus on was just the understanding of a square inch. So that way they have a better understanding of it. So
Before this activity, for this lesson, did they have, what type of experiences did they have with square inches or inches squared?
none whatsoever. I think that with our curriculum that we're using, it was very limited in what they had to do. I know that we looked at the practice problem and we used grids. So we used kind of like an array to figure out what the area of a certain figure was. So it was real brief. So this is the first time they've really actually used manipulatives to figure out the area of a closed figure.
So before they were using arrays in a square?
Yeah.
Or arrays in a rectangle?
Yeah.
But not offset like this?
Yes, that's correct.
They weren't offset. So they had like 3 times 4, 4 times 3, that sort of thing, so that they could understand what multiplication is, in
Yeah.
terms of area. So given that, then did they have any experience before with perimeter?
None.
No? So this is the first time, so it's kind of cold for them in terms of area and perimeter. So how do you think they did in terms of not having experience with area and not having experience with perimeter?
I think they handled it pretty well. I mean, looking at the solutions that they all came up with, the strategy that, obviously most of them used was gridding up the paper in the square inches
Yeah.
and using those 6 tiles to basically draw the grids on the whole closed figure, and be able to count them. I think they did pretty well with that.
Yeah.
I was hoping that they would actually look at the first problem. I know the last group that I had talk about it, they started to jump into multiplication. But I know that it will work for numbers 1 and number 2 because they're both regular rectangles. But then I wanted to see if they would actually divide and see that there's actually multiple rectangles in these irregular shapes right here.
Yeah, so this is going to be, next time you work with them, this is going to be their previous knowledge,
Yeah,
isn't it? Yeah, and that's what you were thinking when developing this. This will be the previous experience. Lesson 2 will be something similar, but then they'll get into multiplication and dividing up the offsets.
yeah.
Okay. So as you're going around, so you anticipate during, and then you talked about your the launch, and but then you went into the explore. Excuse me. You went to the explore piece. So as you then gave them the lesson and the worksheet, and you started monitoring, what were you looking for as you were monitoring?
I was basically looking for what kind of strategies they were using. Obviously, I chose that they only would use 6 tiles just to see what kind of strategies they
Yeah,
would
that
come.
was interesting that you limit them to 6 tiles.
Yeah, and I was thinking, I wanted them to come up with different ways that they could figure this out with only 6. So, I mean, I think that providing them with, as many tiles as they need would have been a little more simpler for them. It wouldn't really make them think outside the box. I wanted them to see how they could actually figure out the area, but also be able to maybe draw lines and grid it up. And then that's what I saw. I think that they were able to see, maybe patterns or roles and start to see for themselves. And I think that allowed them to visualize what they would actually be looking at, because I recall from one group, I asked them, what strategy would you use if you didn't have any tiles? And they said, well, we could split this in half and cut this in 2 parts, and you could see that there's 6 tiles in here. So I think that by limiting the tiles that they use, they were able to just take it a step further and understanding exactly what they were doing by tiling it up. Rather than just counting a bunch of squares, they were able to figure out how it works.
So then, as you were monitoring, you were selecting which ones were going to go up there and present. So there was one group that went up there, and you sequenced them in a particular order. But then you said no one else did this except this one group. And they actually took the square, divided up into 4 smaller squares within the larger square, and they had 2 on the vertical, and on the horizontal they had 2 again. They said 2 times 2 is
4.
Is 4. Did you guide them towards that, or did they come up? Were there any particular questions that you asked them,
Well,
or did they come up with it themselves?
so basically the way it happened was they were already done, and before the lesson even started, I had challenged them to figure out other ways of solving this problem without using tiles. So they already knew that, that's something that they had to keep in the back of their mind. So then once they finished, I said, okay, can you show me a different way you could have figured this out? And then they jumped into addition. Well, there's 2 plus 2, that's 4. This one's 3 plus 3. So they're actually looking at rows. So they're using addition, repeated addition. And then I said, well, maybe you want to think of, maybe there's another operation that might come in. Maybe there's another strategy or something that we've already done that might come into play, and try to figure that out. So I just left them with that, and then they pretty much jumped into it. And then one of the students said, oh, I know, we could use multiplication. And then I kind of left after that. So, and then I came back, and then that's what he was able to tell me. But I think there was still a little misconception there, because he went, 2 times 2 was easy for them to figure out that 2 times 2 is 4. But then they kind of got confused with the 2 times 3, because they went, at first they went 3 and 3, because one of the partners was still looking at the row of 3 and the row of 3 in the bottom, and they said 3 times 3 is 6. And then I said, is 3 times 3 really 6? And then the student that initially thought of the multiplication said, no, 3 times 2 is 6. And I said, where did you see the 2? Because they were able to show me that there's 3 rows on the top, or 3 sections on the top and 3 sections on the bottom. Then I said, well, where did you find the 2? And he said, well, there's 2 parts. And that's where the 3 times 2 was. And then that's...
And it was interesting to me that they could not see this as an array. Maybe the squares are too big.
Yeah.
Whereas, we're used to seeing, the students are used to seeing arrays as much smaller, And then, that's an array. And I count this side, the vertical, and I count the horizontal, and then I multiply those 2. But here, the arrays were much bigger. The squares inside were much bigger than what they're used to seeing. So then, could they transfer that to one of the offsetting, where they have a rectangle and then an offsetting rectangle off to the right or to the bottom?
That's what I would expect for them to be able to identify that tomorrow. And I think that the way that our strategy is, we've been using and we're doing our practice problems. So we do work with our regular pencil, and then we take a colored pencil and then we draw over what we've already done, so they can see. So tomorrow I'm expecting them to see. Okay, do you cut this number 3 in half right there? What do you see? A rectangle. Well, how long? How many segments is it? And then how about on this side? So then we'll be able to write those with the colored pencil over, so that they work together.
So you're in the explore phase of your lesson, then you were monitoring, then selecting. How did you sequence? How did you come up with the sequence that you asked them to, to come up in?
Well, the first group obviously was the misconception, the one
Yeah.
that was
Yeah.
inaccurate. So I went with them first because I wanted them to show what they did without really knowing that everybody else was had a different solution from them. Because if I picked them last, obviously there would have been some insecurities there about their answer.
Yeah.
So the fact that I picked them first, I wanted them to explain what they did and also to question a lot of the other groups that were also working on a similar problem, to look at their work to see maybe we did something wrong.
Yeah.
But to look at that. So I picked them first, a misconception first, and then I picked the one that was a little above that, but I think the way I sequenced it was each group took it to another level. You know, the first group was obviously a misconception. The next group was focused primarily on just the tiling and counting the tiles. The third group that I picked looked at reflection. I thought that was pretty interesting, and I know that the student that was talking during that time was a bit nervous with the camera right there.
Yeah.
But I remember her as she was saying how she made the pattern on the left-hand side,
yeah.
and then it just flipped over, and she was able to kind of slide it over, and
Yeah.
it was still the same.
Yeah,
So it was
still the same.
double. So it was 5 tiles, slide it over, is another 5 tiles, and it's just flipped
Yeah.
over. And I liked how she said it like that. And I was hoping she would have said that, but I know that she got caught up.
Yeah,
in,
she was a little nervous
Yeah.
about that, but she did explain that. Okay, so first we got 5 over here. Oh, then we saw the same pattern on this side.
Yeah, just
or
flipped
that
over.
We saw a square over here, like the square we saw here. So they were looking at patterns. So she just found the mirror image on the other
Yeah.
side. Yeah.
So I wasn't, so that was the next thing that I wanted them to share with the group. And the last group I've called because they were taking it to the multiplication level. So I figured that that was going to be my segue into the multiplication portion of it, the finding the site length and using that to find the area. So
So the last of the 5, so the last of the 5 practices is connecting. So how did you connect finding the area to the tiling in the 1-inch square?
So basically the way I connected it was we looked at the tile again, and we looked at the fact that the tile is 1 inch by 1 inch. So that's our square. So how many squares did it take to fill in these closed figures? And that's pretty much how I tied it in together toward the end.
Yeah. Okay.